Another thing I want to mention is, although we have reference user experiences, you are not required to use those to be compliant. There is a small subset of pieces, specifically some UI framework pieces, that would be required, but not the complete experience. So you can go off and do your own completely different user experience and still be MeeGo compliant. Really important to allow innovation in the user experience. So we're working on a compliance program and test suites to go along with the spec. And that will cover, as I said, applications and devices and distributions. And your ability to use the MeeGo brand will be based on passing these compliance tests. This is something that we will have in place for MeeGo 1.1, so by October. We're going to actually be discussing some of the additional details in the technical steering group in August. And you'll start to see more of this content in terms of the spec and the tools start to be released in the August timeframe as well. So very soon you'll see an additional level of detail on what this means and how it's actually going to be implemented. The overall goal, though, is to make it simple and straightforward. It'll most likely be a self-certification program initially, so there won't be a large cost or investment required to do it. So we're trying to make it fairly easy to do and make it very clear what you need to do to be compliant. And I think we've touched on all of the elements here in terms of open source software stack, one set of APIs. The 6-month release cadence, I think, it's very challenging for the project, but it's also one of the benefits in terms of the rapid innovation of MeeGo. Twice a year you're going to see a new release, new kernel, a lot of new content. So we're hard at work at 1.1, and 1.2 is right on its heels, coming out in April of next year. Just summarizing what we've done so far, we launched the project, we did the netbook release in May with MeeGo 1.0. If you've been following that, you may have noticed we just did our first update a few weeks ago. So a lot of new bug fixes and updates for the MeeGo netbook stack. And then the handset day one, which was really the opening of handset development for MeeGo 1.1. Happened about a month ago. So we've made a lot of progress. We've only been around as a project for 6 months. So I think I'm personally pretty excited about what we've done so far. And this is really just the very beginning. If you think about the timelines for these projects, we're a very young project. I think we've made some great progress, and there's a lot more to come. Which leads us to, the MeeGo architecture. And I know there's a lot of detail on the slide, and I'm not going to talk about all of the boxes, but I'll kind of give you the overview and highlights of kind of our philosophy behind the MeeGo architecture, and then also touch on some of the key parts. We think about the MeeGo architecture in sort of maybe two big pieces, and this piece has two parts. So you heard me mention MeeGo Core. That's the part that's under this dashed line here. This is the software stack that's required to be present on every MeeGo device across all the verticals. This is the common part under the dashed line here. And within that, we divide that into what we call the OS base and the OS middleware. So those are the two parts of the MeeGo core. On top of the core, we have the reference user experiences. So we have netbook and handset today. And as I said, I do expect we'll see others in the future. So with that kind of broad overview, let me walk you through and talk about some of the key components at each layer. So of course, in the OS base, MeeGo is based on an upstream Linux kernel, very, very close to the upstream. I think MeeGo 1.0 went out with 2633. MeeGo 1.1 will most likely be 2635. And if you follow the Linux kernel development cycle, you can pretty much predict what kernel will be on. The Linux kernel has a very predictable cycle in terms of their major version releases. We will basically stabilize on a kernel roughly 8 to 12 weeks before the release in terms of locking down the version. So if you map out the projected kernel development cycle and overlay that on top of a yearly calendar, you could almost guess what kernel will be on in a given release. So our goal essentially is to be on the latest kernel that we can consume in the release. We want to try to be at the current version and really be as close to that upstream as we can get, and not maintain a large patch set outside of the upstream. because there's a tremendous cost as the kernel moves forward if you have a bunch of patches that aren't upstream in maintaining those patches. And you also don't get the advantage of all the innovation that's happening upstream. Of course, in the OS space, beyond the kernel, we have all the core system libraries. We are based on glibc. dbus, which is kind of a core message bus for inter-process communication, if you will, and then some other components there as well. So that's the OS base, basically kernel and key system libraries. One of the things that goes along with that is this thing we call hardware adaptation software. This is all the device drivers, for example, that you need to make MeeGo run on a given platform. There are also, if you notice, there's a little gray bar that kind of slides up the side here. That really is to indicate that the hardware adaptation isn't just about device drivers or architecture support in the kernel. There are also other places where you have hardware adaptation. For example, in the media framework, you may have hardware accelerated codecs. It's a good example of hardware adaptation. Or in the graphics, the visual services stack, you may have hardware accelerated video encode and decode. And those are hardware specific, of course. So that's really what this is meant to indicate. This is a set of software that you need in order to run MeeGo on a given architecture and on a given specific platform. And the goal with MeeGo, of course, is to get all of that software integrated into MeeGo. We want all of our device drivers to be in the upstream kernel. We want any other changes that are affecting the middleware to be in line with upstream, because that really reduces the amount of work that we have to do to maintain that software over time. Anytime we have a driver that's not in the upstream, it's a tremendous amount of effort to keep that maintained. Anytime we have a driver that's closed source, it's 10 times harder. Licensing issues aside, dealing with closed source drivers is tremendously painful from a project point of view. So if you're looking at a MeeGo platform, you really want to look for open source upstream drivers. That's a goal that we really are shooting for. So that's the hardware adaptation. Then in the core of the middleware, we have a set of services for different areas. So communications, internet services, visual services, so 2D, 3D graphics, the media services for audio and video streaming and playback and encoding, core data management for things like contacts and calendar data, device services. So these are a bunch of the things that you need to build a mobile device, like the sensor framework, for example, or device health, which looks after things like battery charging, and personal services, which include things like device sync. A couple other things I'll point out here, kind of new projects that you may have heard about in the panel. Ophono, this is the telephony framework for doing 3G voice and data. Conman is the connection management for managing Wi-Fi, Ethernet, WiMAX, and 3G data connections as well. So these are kind of key new projects that you see within MeeGo. Many of the other things in here, these are pulled from upstream, so there should be a lot of familiar names in there. Above the middleware services layer, we have what we call the MeeGo APIs. And of course, there are a lot of APIs down here, but then there are also some APIs that are special. And they're special in the sense that we're going to make a compatibility promise and say that if you write your application using these MeeGo APIs, you can be assured that it will run on the next version of MeeGo for some fairly long period of time, maybe a couple of years. It's not forever, of course, but it's binary compatibility for multiple releases. So those are the MeeGo APIs. As compared to these platform APIs, you can use those in a MeeGo compliant application, but they may change from version to version. So there's more of a burden if you're using those. In the current MeeGo, in MeeGo 1.0, we have Qt. It's actually Qt 4.6 in MeeGo 1.0. This is kind of reflecting more where we're going with MeeGo 1.1, where we're going to bring in also the MeeGo web runtime. And I'll talk a little bit more in the next slide about a couple of other APIs that are new and coming in.